All right, welcome to our video for logarithmic differentiation. This is a good one. Lots of fun coming up here. So first things first, we got to know some formulas. So these are some formulas you got to memorize. Derivative of ln of x is 1 over x. And then derivative of just any log function in general is 1 over x and times ln of whatever your base is on the bottom. So those are two things you got to memorize. When you start to have actual functions inside of here, like if you have like ln of like x squared plus 1 in there or something like that, then it gets a little bit more tricky because you got to use chain rule. So let's go for it. Oh, exactly what we're going to do in this first problem. So just like chain rule, for a problem like this, you would do the derivative of the inside first, which is going to be x squared plus 1. What's the derivative of x squared plus 1? 2x plus 0. So it's going to be 2x times the derivative of the outside here is ln. It's just going to be 1 over x squared plus 1. So our final answer here, combining this together, is going to be 2x over x squared plus 1. So that's using chain rule. So a lot of these log functions are going to involve chain rule. So here we go. So we got a nice fun problem here. Let's take advantage of the fact that we know properties of ln's, because if we were to just go right in and dive in here and take the derivative of the inside, well, you have a product rule right here, and a quotient rule, and a chain rule. Do you really want to do a product and a chain and a quotient? I don't want to. But since this is ln, I know the very special ln rules. Here they are. I know that this is the same thing as ln of x squared plus ln of sine of x minus ln of root 1 plus x. And we're going to do d over dx of all that. Take the derivative of all that. So all I'm doing right now is I'm just separating these to make it so much easier. Okay? I can even make this even easier from here because of more log properties that I do now. You remember the log property of if you have an exponent, you can put it right out in front. So we're going to do that on this front one and this back one right there, because what is this really the same thing as? 1 plus x to the 1/2. So it's really going to help us out here. So before I even take the derivative, I'm just setting it up using my algebra skills. So I'm going to go 2 ln of x, which will that be pretty easy derivative, plus ln of sine of x minus 1/2 ln of 1 plus x. And now I'm just taking the derivative of 3 separate things, much easier than the original problem, doing your product and a chain and a quotient. So here we go. Let's start taking the derivative now. So this is going to be 2 times 1 over x. All right. And this is going to be derivative of the inside there, because it's sine. So derivative of the inside is going to be cosine times 1 over sine. So that one was a little bit of chain there. Minus, this was ultimately a little bit of chain here as well. So minus 1/2, the derivative of the inside, 1 plus x is just 1. So times 1 times 1 over 1 plus x. And all we got to do now is just clean it up. So we're going to get 2 over x plus cosine x over sine x minus 1 over 2, 1 plus x. And that's it. Now, if this is multiple choice, there's a good chance they actually are going to play with this a little bit. Do you remember what this cosine over sine is equal to? Equal to cotangent. So if this is multiple choice, you'd probably see an answer look like this. You don't need to simplify this. I just want to make you aware that it's totally possible for it to happen. All right, last part of these notes. This can be quite the bear to do. Logarithmic differentiation. Get it on the screen there. Here's the big deal is you only use logarithmic differentiation only when you're told that you have to use it. Sometimes it's totally awesome and it really helps us out. Sometimes it makes things a lot more difficult. So only using you're directed to. So let's say we have a function right here and it looks absolutely nasty. And it is telling us to use logarithmic differentiation here. What we can do is we can do what we did in the last example and try to use our ln laws to exploit how easy the problem really can be. But if you notice, there is no ln on this side. So what do I got to do? I got to take the ln of both sides here, and then now I can split everything up. And then I have just a teeny weeny bit of implicit going on there on the left. So all I'm going to do here for this first step is go ahead and make this an ln of y equals ln of x to the 3/4 square root of x squared plus 1 all over 3x plus 2 to the 5th. And that's totally legal. Okay? So now before I take the derivative of anything, I'm going to just clean this up a little bit. So I'm going to get ln of x to the 3/4 plus ln of, I'm going to write that as x squared plus 1 to the 1/2 because I'm going to end up doing that anyway. I might as well do that now. Minus ln of 3x plus 2 to the 5th. And now all I'm going to do now is just pull all those exponents out in front. So it's going to give me 3/4 of x. That'll leave it pretty easy when I take the derivative of, plus 1/2 ln of x squared plus 1 minus 5 ln of 3x plus 2. Okay. Now it's all set up pretty nicely. So I'm going to take the derivative of the left side and the right side. And this is what some people forget about, is take the derivative of the left side. What is the derivative of ln of y? It's going to be 1 over y, and then you got to tag it. So it's dy dx. Which is perfect, because that's what I need is dy dx. That's the same thing, by the way, as y prime. Okay? The derivative here is going to be 3/4 times 1 over x plus 1/2. Derivative of the inside here is 2x. And then this is going to be 1 over x squared plus 1. These are all time signs, by the way, these dots. And then minus 5. Derivative of the inside is 3. And then it's going to be times 1 over 3x plus 2. Let me just clean that up a little bit here. I'm going to keep this 1 over y over here just for 1 second. That's going to give me 3 over 4x plus x over x squared plus 1. Those two, the half and the 2 are going to cancel out. Minus 15 over 3x plus 2. Now, I need to get the y on the other side because I just need dy dx. So dy over dx is going to equal all this stuff we just did, 3 over 4x, which is on the screen, plus x over x squared plus 1 minus 15 over 3x plus 2 times y. Oops. And then your answer is never going to have a little y in it. So all we're going to do now is substitute this y for this right here. So we're going to get a final answer of 3 over 4x. I know this is probably so fun, you watching me write all this stuff down. Squared plus 1 minus 15 over 3x plus 2. And that is all times, substitute my y in to be x to the 3/4. And you don't need to clean anything up beyond this. This is it. And that's your final answer. Is this guy, should I add a highlighter? I don't. It's going to be this guy right here. The entire part. Okay? And that is logarithmic differentiation. Again, only do it when they ask you to. And if you ever need help, these are the 3 steps that we do, is just rewrite, pretty much getting down here to gray, then find the derivative, and then clean it up. That's it.